What is the ratio of the 8th term in this sequence to the 5th term? As always, I start by going to the end, which is where the question is. Now, right away, we're told this is going to be a sequence question, and the word sequence just means list. And the important thing you have to avoid when you're dealing with sequences is confusing the number of the term in the list with the actual element of the list. 8 terms is not so bad, so I'm just going to roll up my sleeves and make myself a list. It's not always possible to approach list problems this way, but if they're going to be nice enough to make it short, then we're just going to hammer it out. Now we've got to actually read the question at some point, and we're told after the first term in a sequence of positive integers, the ratio of each term to the term immediately preceding it is 2 to 1. Whenever we're presented with a ratio, we have to pay careful attention to the order in which things are stated, because that tells us mathematically what's happening. So each term to the term immediately preceding it is 2 to 1. Some of you may get this right away and understand what to write down, but for those of you who need to unpack this before it makes any sense, this is how you unpack it. Word by word, each term. Let's pick the 4th term. We'll call it x. The 4th term, which is x, to the term immediately preceding it. The term immediately preceding the 4th term is 3, which we'll call y. So the ratio of x to y is 2 to 1. Okay, what does that mean? That means we can go one of two ways with this. We could start writing down equations for relating x to y, and it's either y equals 2x or x equals 2y, I don't know. Or we could just say, well, what if x was 100? That would mean that y would be 50. So 100, 50. Let's fill in the rest of the table, or the rest of the list. 25, 12.5, 200, 400, 800, 1600. What is the ratio of the 8th term to the 5th term? Looks like 16 to 2. So 1600 to 200, which is 8 to 1. Now that seems a little shaky. Seems like we ought to do a little more due diligence in checking up on that. So let's see what would happen if we started our sequence with 1. Then we'd have 2, 4, 8, 16, 32. I'm going to track down here the number in the sequence. 1, 2, 3, 4, 5, 6, 7, and 8. 64, 128. We need 128 to 16. 128 to 16 is the same as 64 to 8, I just divided both sides by 2. Now it's pretty obvious I can divide both sides by 8, and I get 8 to 1. So it checks out. Now I'm sure some of you math purists out there are just nauseated by how I did this, and you're just dying for me to mention that this is a geometric sequence. So for our second method for solving this, we'll just do a little pre-calculus or math analysis lesson. A geometric sequence has a common ratio of r, and so whatever the first sequence element is, call it A1. The next one will be A1 times r, A1 times r squared. So this is the first, the second, the third. I'll do one more. A1 times r cubed would be the fourth. And the nth term in this sequence will be the first term times r to the n minus 1. Now, of course, in our problem, we were given r equals 2. So, regardless of what the first term was, the fifth term would be a1 times r to the fourth, and the eighth term would be a1 times r to the seventh. And if you want to figure out the ratio, it would be a1 r to the seventh to a1 r to the fourth. Of course, the a1's cancel, and we're just left with r cubed to 1. And of course, if r is 2, then this becomes a to 1. So there you go. Super fancy math way of doing this. Of course, I prefer plug in a number and go with it.